Welcome to The Explainer. You know, we hear all the time about these incredible AI models, but have you ever stopped to wonder how one of them goes from just a cool experiment in a lab to actually being out in the real world, running a business? Well, today we're going to pull back the curtain on that journey. It's a process called Model Operationalization.
See, it's a story we see all the time in the AI world, right? A project looks absolutely brilliant. It aces every single test you throw at it in the lab. But then, nothing. It never actually delivers any real-world value. It just gets stuck in this place the industry calls pilot purgatory.
And you know what the reason is? It almost always comes down to a failure to conquer what's called the last mile. Now, this has nothing to do with how clever the algorithm is. Nope. It's all about let's call it the gritty, complex process of actually plugging that algorithm into a live, messy, unpredictable business. And that final step, that's everything. It's what separates a cool science project from a real business solution.
So to get through that last mile, you really need a map. And that map has a name, Model Operationalization. Think of it as the playbook, the systematic framework for actually putting AI to work. Okay, let's dive in and look at the core components.
Okay, so to really get this right, you've got to understand that an AI model basically lives in 4 different homes throughout its life. I love this analogy. Just imagine. One home is the architect's office, another is the lumberyard, the third is the actual construction site, and the last one, well, that's the crew doing ongoing building maintenance. All right, first up, we're in the architect's office. This is the data scientist's lab. You know, it's the world of Python notebooks and endless experiments. It's where they explore all the data and meticulously train and tune the core predictive engine. And this is really important. We're not talking about building some user-facing chatbot at this point. No, this stage is all about creating that specialized predictive brain that's going to power the whole thing later on.
Next up, we head over to the lumberyard. And this is a totally separate environment dedicated to one thing, preparing the fuel for your AI engine. And that fuel, of course, is the data. This involves, well, the whole shebang, collecting and cleaning the raw materials, making sure everything's labeled correctly, that it's secure, and that it's ready for construction.
And this is where things get really interesting. This quote kind of reveals the dirty little secret of AI success. You might think it's all about the fancy algorithm, but it's not. It's the plumbing. A staggering 80% of most AI projects is just this unglamorous, behind-the-scenes data work. And think about it, if that data foundation is weak, the entire structure is just going to collapse.
So now we're at the third home, the live construction site. This is where the rubber meets the road, where the model finally gets to interact with the real world, and NASA has a perfect example of this. See, they used to try and predict aircraft maintenance by looking at old stored data. We call that batch processing. But then they realized, wait a minute, it would be way more powerful to use real-time stream processing, applying their model to live data as it's coming off the plane. And that shift, from analyzing the past to reacting in the now, that's the very essence of the operational environment.
But here's the thing. Launching the model, that's not the finish line. Not even close. It's actually the starting line of a whole new race. Because once a model is live, it needs constant care and feeding to stay effective. And this is where management and governance, our building maintenance crew, finally come in.
First up, you absolutely need governance. Just think of this as the official rulebook for your AI. It lays down the law on who can use it, how they can use it, and it keeps a detailed record of everything. Take Coca-Cola, for example. When they built models to help moderate their brand content on social media, they couldn't just, let it run wild. Of course not. They set up a whole governance team to act as a failsafe, just to make sure nothing inappropriate ever slipped through.
Okay, next is monitoring. This is basically your AI's 24/7 health check. You're always tracking its performance, its accuracy, and this really critical concept called drift. So what's drift? Well, it's what happens when the real world changes, but your model stays the same. Imagine a model trained on pre-pandemic shopping data. Now, all of a sudden, it's dealing with post-pandemic behavior. Its predictions are going to drift and get less and less accurate. Monitoring is what catches that before it becomes a huge problem. And you have to remember, an AI model is a seriously valuable company asset, so it needs to be protected like one. Model security isn't just some technical detail you can ignore. No way. It's all about controlling who gets access, protecting that priceless training data it was built on, and, crucially, defending it from attacks designed to trick it or even break it.
All right, now let's switch gears and talk about the new frontier that is changing literally everything, generative AI. I mean, these models bring these incredible, almost magical capabilities, but they also bring a whole new, unique, and pretty challenging set of risks when you try to put them out into the real world.
You see, the amazing thing about these big foundation models is just how accessible they are. It is shockingly easy for almost anyone to start building with them. But that's a real double-edged sword. Why? Because it often means people are rushing to build things without putting any of the necessary operational safeguards in place first.
Think about it. With traditional AI, you often build the whole system yourself, from the ground up. But with a lot of these super powerful generative models, you're just accessing them through an external API. What does that mean? It means you have way less control. The company that owns the model could change it, they could update it, they could even jack up the price overnight. And all of that introduces a whole new category of risks that you've got to be ready for.
And listen, these are not just some theoretical what-if problems. Oh no, hallucinations, where a model just confidently makes stuff up. That's a real thing. Models can actually get dumber when they're updated, and you have to constantly be on guard against adversarial prompts. These are these cleverly disguised inputs that users create to try and trick the model into breaking its own rules. These are active, real-world, daily challenges for anyone running a live Gen AI app.
So this brings us to a really critical idea. Operationalization is not a one-way street. It's not a straight line from A to B. It is a continuous cycle, and sometimes, honestly, the smartest and most important thing you can possibly do is know when to stop and go back.
So, for example, let's say your monitoring tools are screaming at you that the data your live model is seeing, well, it looks nothing like the data you trained it on. You can't just ignore that and push forward. You have to hit the brakes, stop, and go all the way back to phase 2 to rethink your fundamental assumptions about the data. Or, hey, what if the model is technically working, but it's just too slow? Or it just plain doesn't perform well out in the real world? See, that's not a data problem. That's a model problem. And that means you've got to go back to the development phase to refine it, optimize it, or heck, maybe even rebuild it from scratch.
And then there's the toughest one of all. You get all the way to deployment day and you suddenly realize that this thing you've built, yeah, it's technically impressive, but it doesn't actually solve the business problem you started with. That's when you have to have the courage to go all the way back to square one, all the way back to the beginning to rethink the entire project.
Okay, so with all these moving parts and all these complexities, how in the world do you know when you're actually ready to push the button and go live? Well, here's a quick checklist to help you make that super crucial go, no-go decision.
First things first, you got to answer the fundamental how questions. How are you going to deploy this thing? Batch, streaming, you need to have that defined. Where is it going to run? In the cloud, on-prem, on an edge device? You have to know. Is your tech stack actually built and ready to go? And finally, is there clear scaffolding? And by that I mean, are there simple guides and tools so that other developers can easily connect their apps to your AI? You absolutely need solid answers to all of these questions before you even think about launching. And second, you need a plan for the day after. Because this is all about making sure your model doesn't just launch, but that it actually continues to thrive long-term. Is it integrated with your existing DevOps pipeline? Are your monitoring and governance systems fired up and ready to go? This is the stuff that guarantees the long-term health and security of your model.
And that brings us to the final and maybe the most important thought of all. The real key to this whole mindset is to always be asking what's next. Because a successful launch, that is not the end. It's the starting line. It's the beginning of a cycle of continuous improvement, of learning, and of iteration. Because in the world of AI, the journey is never, ever truly over. Thanks so much for joining this explainer.